Hey guys, welcome to Coding Science. Today we'll take a look at how we implement the methods associated to the stack with pseudocode so that later on we can implement them in any kind of language that we want. So let's get started. So here is the algorithm push. And we'll try to make a drawing here to make it more understandable. It's not very complicated. You see there is 4 lines. It's not the most complex algorithm, but it's nice to go step by step and see what's happening. So we start by using the push function and putting an object. So we'll need the O object here, that is here. That will be that box. Next, we'll need a representation of our stack with the variable n, p, and the stack itself s. But as you can see, the stack itself, it has actually, depending on the n number here, will have different size. So we'll first decide how big we're going to have our stack, how many cells we're going to have, and we'll decide for 5. Then we'll initialize our p to -1. There we go. And I will explain in a second why. And we'll create our stack, our array that we call S. It's an integer, it's an array of integers, and it has 5 elements. 1, 2, 3, 4, 5. And as you can see here, the array, first element of the array has an index here of 0 that works itself up to 4. Now, this is the reason why we start p at -1. I remind you that p is the pointer. We represent it here. It's the pointer that will point at which cell is the latest element in the stack. But if p was pointing on 0, just standard, then you wouldn't know if 0 is empty or not, right? Because if p is on 0 from the start, then you don't know if there is anything in here. Because even if it's empty, it's still on 0. And if it's full, it's still on 0. So that is a problem for us. We need a way to know if the stack is empty or if the stack is not empty. And that is why we start p at -1 here. And then we'll need some elements. We'll make a connection to show here. And then we'll have some elements. There we go. So now we're ready to start playing a little bit with the function, with the method. Keep mixing those two. So let's see. We'll start with the 2 here. So we'll use the function, the method push on the integer 2. So O here will take the value 2. Okay, so now we've done this part. We'll go to the next. We do a check. If p plus 1 is equal to n, then we maybe do something. So p plus 1. P is at -1 at the moment. We'll add 1, that becomes 0. Now n has the value 5. 0 is not equal to 5. Then we will ignore that line completely and we'll jump to that line. So here, first we'll attack it from that side, and usually you work that way around. So p plus 1. So we haven't changed the value of 0. I mean, this here, we just did a check. We haven't changed the value of p. So p is still at -1. So p plus 1 is 0. Now, this arrow here means that in pseudocode, this arrow means that we will put this value, the value of p plus 1, into p. So -1 plus 1, 0, we'll put that 0 into p. So we'll replace it with a 0. Okay. So now the p value is at 0, so the pointer now points at 0 here. It doesn't point at -1 anymore, it points at 0. This is important. The O object, which is this one, with the value 2, there is the arrow again. So we'll put the value in O into the array S at the position P. The position P here is 0. That is the array. That's the position 0. So we'll need to put the value in O, which is 2, into that position. There we go. And now we're finished. We've done the algorithm for the push function. So now we use return. That means that we exit the method. So we're done with 2. Now let's use another number to see it again a bit faster maybe, but let's use another number. So now we'll use the push method again on 6. So O, which is here, becomes 6. Okay. So now we're going to check. P plus 1, is it equal to n? Well, P is equal 0 now, not minus 1. It's equal 0. Plus 1, this is 1. 1 is still not equal to 5. Fine. Then we will ignore this line and we'll jump directly to this line. So P plus 1, 0 plus 1 is 1. Then we will put that value 1 into P. Let's do it. There we go. Fine. So P has now the value 1. So it will jump up to the element in the stack here. Okay, next line. Now we take O, the value in O, and we will put it in the stack S, the array S, or I call it the stack, but it's actually the integer array S, at the position P. P is 1, we see the pointer here. Then we will put 6 in here. There we go. So now we have stacked it up. And as you can see, P is pointing on the latest element of the stack. So we're finished and we return. And we'll do this for 3 more numbers. So we'll fill it in like that. And it's the same process. We change P every time and we'll check it. But I want to show you, because it's no point in doing this 5 times, but I want to show you what happens when the stack is full. So now we are in the situation where P is in position 4. You can see here P is equal to 4. And we still have a number here. So we have minus 2. And let's say that we didn't put any checks. We didn't use any if empty function or is full function. We didn't use is full, so we didn't check if it's full. So we are trying to push a number when our stack is full. So let's do this. We push the number minus 2, the integer minus 2, into our stack. So where we go? O takes the value minus 2. Fine. So now we do our check. If P plus 1 is equal to n, so P is 4 plus 1 is 5. And this time it is equal to n, which is 5. So 5 equals 5, that is very true. So what now? Well, we'll do this here, this line here. So you see the line has a return. That means that this will not be executed. We will, after doing this, we will actually exit the method. So this will not be done, and there will be no changes done to the stack. Okay? This part here, a stack full error, that's dependent on how you handle your errors and how you program your software, and also what kind of language you're using. So this, we're not putting any details in it. It's just you will generate. If this would happen, it should generate an error that would be handled by your program. Or just you can just make a print saying there is an error, blah blah blah. But the important part is that nothing happens to the stack. You didn't do any changes. Okay? Because if you were, for example, that you put this after this, then suddenly the minus 2 may have come to here, or you would crash, or there's many unforeseen results that can happen. That is why this is here. It's to stop the program, is to stop the algorithm before you're going out of your array. So yeah, that's pretty much the important part. And then you would return and nothing would happen. So -2 comes into O, but it doesn't do anything. So that's it for the push method. Let's take a look now at the pop method. Here is the algorithm. Not very complicated. There is a few changes though. We won't be working with values that we put in. We start with a stack that is already full. We won't use the variable O, but we'll use a new variable that is E. E will be the result, and we will return them in a sequence that we'll see here when we're returning the values from E. So let's start with the first element. So we start on top because it's the latest element that has been push into the stack. P is at 4, so we're here. The first thing we do is to check if P is inferior to 0. In this case it's not, it's 4. So we will ignore the error and we'll just go to the next step. Now, as we've seen, this take the value in S at the position P. So here 4, this is 9, and it will put it in E. There we go. The next step is to take that cell in S at position P, and we're gonna put a null value in it. It's not a 0, it is null. In programming in integers, with integers, 0 is not a null value, it is 0, it's a number. And we don't want a number here, we want it to be cleared, completely cleared. So we will remove the 9, it's still in E, but it's not anymore in here. So by doing this, we are completely removing this value. Then the next step is going to update the P. So we'll take P minus 1 and we'll put that in P. So 4 minus 1 will become 3. And now we are finished. We will return E and get our first sequence. There we go. Our first number in our sequence. And P has moved down to 3. Now, if we were going to do that again, function pop, we would get the same result. And now minus 5 would become extracted here, and P would be 2. We will retract 1. So we'll do the same. So that's fine. But what if we are in a position now we have one last element? All the elements have been extracted with pops. And now we are in with the last element. What happens then? So let's do this. We first check if P is inferior to 0. Well, it's not. It is equal to 0. So the error is not generated. The value S is put in E, as we see here. Then we will put a null in the position 0, because we're at 0 here. It will be clear. And then the pointer that is pointing on 0, we will subtract 1 and put that value in P. So it will be minus 1. Then the pointer jumps down outside of the array. So now we didn't get any error, we emptied our stack, but what if we are trying to pop again? What would happen then? Well, P is now inferior to 0. We would generate an error. Like I said with the push method, this can be handled differently, different ways, but the important part is that the return happens here. So this part will not happen. Okay, we won't try to extract a value from E because we are outside of the array. It wouldn't work. That would generate also an error. And there is nothing to nullify, and P won't change any value. So we're not doing that part. And you wouldn't get any result in here. So that's pretty much it. Now let's take a look at the peak method. Here is the algorithm. And we'll take a walkthrough into what it does. Now, we set up in this, we go back a step backwards, and we come back to the last element. This will work in any elements. If you have 1, 2, 3, 4, 5, doesn't matter. Just use an example here. So now P is in position 2, position 0, sorry, and the number 2 in here. So let's use the function peak. We call peak, does not take any parameters, and we just should give back the last item that has been stacked. And in this case, this is this one. So let's see. First, we check if P is inferior to 0, then we may do some error, return an error, but in this case, P is equal to 0, not inferior. So we'll skip that line and go directly to that line. Here we take the value from the array S at the position P, which here is the value 2, and we will put it into the variable E. There we go. And then we will return E. So we get in our sequence of results, we'll get the number 2 here. But what if we do it again and we peak again? What would happen then? Well, as you see in here, we didn't do any changes to P. We didn't subtract 1 from P, so it's still at 0. And we didn't nullify the 2 number in the position 0. So if we do it again, we get the result, the same result, and we get the second number 2 here. So our sequence simply has 2 number 2s, one after the other. So that's the main difference with peak, the peak function, compared to the pop function. It retrieves a number, it gives you the number without deleting it. So now, what if we are in this situation where the array is actually empty and P is equal to -1? So let's see. We call our function peak, or a method peak. If P is inferior to 0, then in this case it is inferior to 0, it's -1. So we return an error, and since we return here, this part here will not be done. It will be ignored. So now we just pop out of the method and we finish it. We do not collect any sequence, any number for our sequence. But we do generate an error that needs to be handled in your program when happens. That situation here in peak and pop and stack, we always have some possible errors if we try to either add an element when the array is full, or when we try to pop an element or peak an element when the array is empty. That generates error. That is why there are 2 more methods that we'll see in a moment to help us beforehand. We can try to see if the stack is either empty or full, so we avoid those errors. So the first function we see now is the empty method that I remember. It's supposed to show you, to give you an idea if your stack is empty or not. So here is the algorithm. It's a very simple algorithm. We are now in a situation where we have a stack that is not empty. We still have a value in it. So let's call our function. We call the isEmpty function method. So if p, well, now we're using p to see if we are empty or not. We're not checking any values. We don't go through the array because p is always on top of everything. So if p is not negative, I mean it's not inferior to 0, then if it is, then it's true. But if it's not, then we go directly to the else here. We can see p is equal to 0, and then we put the false value into e here. Now, I put false here in many in actual, when you would program and get a Boolean value, you would get a 0. We generate a 0 value here, a false value, and we get a sequence Boolean false. Okay. But now, what if we are in this situation where where the stack is empty and p is equal to -1? Then suddenly the if here becomes true. And then we will come to that point where e will be filled with the value true, and we will return a true value. Very simple algorithm. It's just, it allows you to know if your stack is empty or not using p. And then we have the kind of opposite, which is the isFull function or isFull method that's supposed to show you if the stack is full. So this is a situation where we are on almost full but not full array. P is the value 3. So let's try to call the full function. We call it, and then if p now, the check we do is still on p. Again, we're using p to see if we're empty or not. So p, if p is inferior to n-1, n is the number of elements, but we want to know if it's inferior to the maximum index, to the highest index in the stack, and the highest index is always n-1, because we have a like we talked earlier, we start in 0 and we add 5 elements. It becomes 0, 1, 2, 3, 4. And in every situation that you will have, if your number here is 1,000, then your last number here will be 999. So you always end up with having to check if p is inferior to n-1, which is in this case 4. So let's see our situation here. P is equal to 3. It is actually inferior to 4. Then we jump to that line here and we add false into our e variable. The else will be skipped because when you have an if else, you always do one of those, not both. So the if was true, we did this one, so this will be ignored and we'll be jumping directly to the return of e, and we will get a false Boolean value from the method. But let's see, if we are in a situation where the stack is actually full and now p has the value 4, then suddenly this one, and this if check here, p inferior to n-1, is not true anymore because 4 is not inferior to 4. Then we come to the else part. We ignore this and we go to the else part. And now e takes the value true and we return it. And we get now the value true. And again, this method is very useful if you want to try and add something to the stack, but you don't know where you are. So you wonder, is there space into my stack to add something? So you call the function isFull that works very well with the if not true, then you would be able to add an element to the stack. Or you could say if isFull equals to 0, then you could add a value. If you're sure that it's equal to 0, it's equal to false. So that's why it's important with the isFull function and this empty function. They help you avoiding the errors from the pop function, push function, and peek function. Because in the end, we want to make some programs that do not generate errors all the time. So that was it for the implementation of the functions for the stack. As I said earlier, we use pseudocode because that will permit you to think more about what's happening without focusing on which language you're using. And then later you can implement it in the language that will fit your needs. So I hope you like the videos. And if you watch this video first, you should know that there are 2 others about the data structure and the concept of the stack. Otherwise, there is the full course containing all videos all together. If you're interested in learning all there is about the stack. Well, thank you guys, and I hope you liked it. Give it a thumbs up if you liked it, and if you wish to follow more of my videos, please subscribe, and see you next time.